Welcome back to another quick installment of Julian's Random Projects. I recently stumbled across Rigged Games, YouTuber by the name of John Riggs, and he's got an awesome series of videos called Open Cart Surgery, where he takes broken video games, cartridge games typically, that people have either sent in or that he has himself, and he tries to repair them if they're broken. Oftentimes it's just a simple cleaning, but every once in a while he'll need one that needs like deeper work and desoldering and swapping out of chipsets and things like that, and ROMs from maybe a bad board to a good board, something like that. And he goes that deep as well. But I got to watch one of his videos where he worked on a cartridge that was beyond repair. It was the circuit board itself was cracked, and so even if he was able to fix it, it just going in and out of a game console would just break. But something about watching John plug in cartridges that were previously deemed worthless and probably would have been thrown away, and to see them light up is just something that intrigues me. And it's like breathing new life into old hardware, or making something useful that was previously useless. I don't know why, but I really enjoy that. Maybe it has something to do with this fantasy I have where I'm the professor a la Gilligan's Island in some zombie apocalypse where things that need fixing are brought to me, or I set up some sort of rogue outpost with solar power and lost N64 consoles that are running on solar and getting them all working and that kind of thing. So to indulge these fantasies, I asked John if he would send me that cartridge that was beyond repair, in hopes that I might be able to fix it, a la zombie apocalypse, and we don't have any other games to play, and no one's making new games, and there's no online app store to buy these old retro games. We have to fix the ones we have. This is that. Let's see if we can do it. So the game in question is F-Zero X, and I've not actually played F-Zero X. I also realized when this came in the mail that I may have jumped the gun. I didn't own a Nintendo 64, so I had to buy one on eBay. I also didn't own any Nintendo 64 games, so I grabbed a couple of those. And also, thanks to John, I learned that the Japanese imports will work in a Nintendo 64 with a slight hardware mod. Very easy to do. So thank you, John, for that. And that enabled me to buy some really, really cheap games that are a lot more expensive in our native language. I mean, when you're playing Mario Kart, I mean, come on. Do you really need it to be in English? There we go. Now, the astute among you may have already noticed that we have a massive crack in this thing. Let me see if we can... I mean, look at that crack. Now, that crack runs all the way through this multi-layer board. It's a 2-layer board. So it's also clear through the other side. Now, my experience with circuit board tells me that this side, because this thing hasn't completely fallen off of the board, it's not separated from it, and it hinges on this side, meaning that this part here folds down and this side stays connected. So these larger traces are now acting like living hinges for this broken PCB. So we're high chance that these are all still connected, but we'll ohm them out. Traces I'm confident are all severed are on this side, and that is pin 35, 34, 33, 32, 31, 30, and so on, all the way down the line. If you weren't sure which of these were broken, I mean, we can clearly see with our naked eye that these are snapped. If you weren't, you would ohm them out across from where they start here to where the trace is going. And that looks a little bit something like this. Let's see. So this might also act as a bit of a how-to for folks that aren't accustomed to using multimeters, volt-ohm meters. They go by many names. I just call them multimeters. And what we're about to do is called ohming out, or checking for connectivity, or checking for continuity. There's a lot of different ways to say that, but we're checking the resistance between point A and point B. So for this meter, it has a handy little beep to let you know that it's touching. Now, when it is beeping, watch this. The meter will go as close to 0 as possible, because there is, between a dead short, there's 0 resistance. There you go. And here, now it's overloaded because it has infinite resistance. There's lots of resistance between these two. It's called air. So that's a correct reading, right? If you had something like a resistor, we checked either end of it. There's conductivity, and it's reading 10 ohms, right? And as it would have it, this is a 10. We should point here so we know what we're talking about. 10, that's the sign for ohms. 10 ohm resistor, and it can handle up to 10 watts running from point A to point B, right? So you get the idea. So if you didn't know where your breaks were, you'd come in here, you put one probe on this side of a pin, and you would connect it to a spot that you know you can visibly see that it's going to, right? You can also check it further out. To give an example, or something I know is connected, is there's this outer, this big thick trace that runs all around the board is likely to be ground, right? Or a common connection. And so if you test here and anywhere else that there's that same big thick trace, you would get conductivity. So this is called ohming it out. You can also use it to check the ohmic value of a resistor. I like to take it off of the beep. You come in and put it on either side of a resistor. There you go. Now be careful that when you're checking components, when you're checking them in the circuit, they might be interacting with other things. Like this particular resistor might be in parallel with another resistor, and so you'd get different values. Same thing with capacitors. All right, so that's one of the basic uses of a voltmeter. I might do another follow-up video in the future and go through some of the basic operations. Maybe even just go clockwise through the dial here and just show you some tricks and tips for using this. But we'll do that in another video. This particular video is going to be all about repairing this board. Now, if I can get it to boot up, then I will come back and epoxy this PCB so that it doesn't break again as it's being inserted into the console. And I was planning on sending this back to Riggs so that he could donate it to somebody or give it away at a convention, but I don't think I'll do that now. Personally, seeing how damaged this board is, it wouldn't be any fun for, let's call him a civilian for lack of a better term. So, you know, some civilian or some nice kid gets this for free from Riggs, and then on the second time he inserts it into his Nintendo 64, it breaks again because the epoxy didn't hold up here. So again, this is more a end of the world zombie apocalypse repair of this thing to see, can we actually play the game? Because in that case, you probably would leave it in your console for a long time, or you'd be more ginger with it knowing that this is the last copy of S0X maybe in the entire world. Now, the type of wire that I would typically use to make repair jumps is something called magnet wire or enamel wire. It's very, very thin stuff, and it's got a small coating over it, so that it just looks like bare wire, but it's not going to short out against things that you lay it over. But again, in a zombie apocalypse, I don't know where you're going to be getting magnet wire from, so my source would be a pair of busted up headphones. Alright, there we have it. I started to run some of the magnet wire, and then I noticed that some of these cracks were like along the pins themselves, and so to jump from there to there with wire would just make it really thick. So I'm going to give just soldering them as a bridge a chance to work. We'll see how that goes. And then same on the other side, I plan on making jumps from the base, the tops of these pins, so that when it goes into the receptacle on the Nintendo 64, those connections only come up about halfway up the pin. So as long as I tapped off on the very top up here, yeah, so long as I tapped off from here and ran my repair wire, the magnet wire, across, you know, maybe route it around here and then connect it to each one of these little vias. Anytime a a connection is made from the top of the board through the bottom of the board through this little cylinder here. Those are called vias. So electrically, each one of these is the same as each one of these. They just go up and through this board, or they go up and underneath this this ROM chip. But the cracks were really faint. They're not really big, and so I'm hoping I was able to bridge those with some solder, as you see here. So I scraped away this green material, which is called solder resist, the name and sort of a giveaway of what it does. Scraped that away, got down to the bare copper, and then made a bridge with some solder. So let's take it upstairs and see if we got it. Heyo. And we're in like Flynn. I will take Riggs' advice and not have audio going for fear of Nintendo taking down this video. Well, if you enjoyed watching somebody resurrect a previously dead Nintendo 64 game, give me a thumbs up and let me know in the comments section. And if you want to see more random projects like this from Julian, just hit the subscribe button so you can get updated with future videos. Thanks.